Okay, so I'm sure a lot of us must have seen in our school textbook something like this. Right? You know what a rectangle is, right? You've seen this.
Yeah.
Yeah?
Okay. Yeah. The length is greater than the breadth, right?
Does that have to be?
That's a rectangle, I know. And here you have this one is longer than this. So that's a rectangle.
Okay.
Yeah.
What about this? Is this a rectangle?
That's a square.
That's a square.
Yeah.
Okay. But is it also a rectangle?
Is it also a rectangle? Okay.
So you say you're a human. Are you also a mammal?
Yeah, of course.
Yeah. So humans are mammals?
Humans are mammals.
So
Yes.
you belong to the category of humans, and you also belong to the category of mammals. So can this belong to the category of square and also to the category of rectangle?
But rectangles are not squares.
Rectangles
Not all rectangles.
Not all rectangles are squares. So
Yeah,
this
okay.
is clearly not a square, right?
Okay. Okay. So
So-
you're saying squares are a special case of rectangle.
Yeah. So we can consider that, right?
Yeah.
Yeah. So
It's possible.
It's possible.
Yeah.
So, but do we want that? Is the question. Why do we want that?
I don't know.
So let's actually a good way to see it is the notation we had created of graphs.
Yeah. Okay.
So if you say rectangle with square versus rectangle and square as two separate nodes.
Okay.
So now what does this arrow mean here?
Wait. I don't. Let me draw that arrow.
Okay.
Okay. This is a rectangle.
Yeah.
Okay. So let me call it like that. Rectangle.
Yeah.
And this you said is a square.
Yeah.
But that also means you have things like non-square.
Non-square. Yeah.
And so there are two kinds of rectangles. Rectangles which are squares and rectangles which are non-squares.
Yeah.
Is what you mean.
Yeah.
So this is a subcategory of this guy.
Yeah.
The other one that you mentioned is you have a rectangle and there's a square.
And then
This is not a subcategory of
in that situation, this is the equivalent of this, right? Rectangle is a non-square. Over here.
Ah, yeah, that is true.
Over here,
Yeah.
rectangle means non-square.
Yeah. So yeah, actually this is non-square.
Yeah. So what is
So actually it looks like this picture. This picture. All that you need to do is take this picture, a rectangle, which is a non-square. I'm doing this, right?
Yeah.
And a square, which is a rectangle. If you just say that, then this is a rectangle. So this looks like the same thing.
Yeah, that becomes exactly the same.
Okay.
Yeah. Unless you define rectangle to mean non-square, and then this is the only
Then we
picture
can
you
do
have.
that, yeah.
So what is the advantage of both of these pictures over this picture? So now it's important to see here, what does the arrow mean? What is the arrow?
Arrow means subcategory, right? You know, so square is a subcategory of rectangle.
Yeah.
That's what it means.
Yeah.
Okay.
So-
Here it is not.
Yeah. So
Okay.
now let's go back to the human mammal case. So now you say mammals have, mammal females have mammary glands,
Okay.
right? That means humans have mammary glands,
Okay.
right?
So right.
Because
yeah.
all mammals have mammary glands, therefore humans are mammals, therefore humans have mammary glands.
Okay.
So here, similarly, if anything is true about rectangles, the same thing will be true about squares.
So a rectangle has four corners.
Rectangle
Angles.
has four,
That means square should also have four corners.
which it does.
Okay. Rectangle has four sides.
Yeah.
So square has four
Four
sides. Okay. That's so all the description of square,
Square.
and most of it comes from here.
Yeah. So here, now try and define square over here. What is a square? In this, that
You mean a
first
square which is not a rectangle?
which is not a rectangle.
Then it is, it has to have four corners, four angles, four sides, but one of them square, so all the sides are equal.
Are equal.
But you have to say that here as well, all the sides are equal.
Yeah, but here all you have to say is that a square is a rectangle with all sides equal.
Here you have to say all those things.
In fact, you can do even better than that. You can say square is a rectangle with only two adjacent sides equal.
Where the other thing would follow, right?
Yeah, it would follow that.
And here you have to say rectangle, the sides should not be equal.
Not be equal. So
Okay.
it seems a lot more complicated there, right?
Yeah.
Here this is easy. Now I'd say, what is a square? A square is a rectangle with two adjacent sides equal.
Yeah. So okay, that looks like a neat idea of using subcategorization
Yeah.
to simplify things,
Yeah.
to predict.
So now from here, where would you go? You would go to
There's no space there. Let's do this.
on this.
Let's do this.
Let's do it here.
Okay. So I want to begin with polygons. No, I want to begin even with
But let's go up rather than coming down. So let's start from square, go to
Start from
rectangle.
square.
Yeah.
Okay. So there is square, and there is
Non-square.
non-square.
Non-square rectangle.
Yeah, non-square. But you're going to say this is a rectangle.
Yeah.
That's what we did here.
Yeah.
Okay. Now let's go up.
Now, how would you go up here?
Rectangle, you could say, is part of it's a parallelogram.
Yeah, you could. So now once again you have a choice. You could say rectangle is a quadrilateral, or you could say
but
rectangle is a
you could also
parallel.
say this is the non-rectangle parallelogram. So
Yeah.
that means a parallelogram.
Yeah, it has this property.
Okay.
But so here you've chosen parallelogram rather than quadrilateral. Why?
Parallelogram, because parallelogram is a quadrilateral.
Yeah.
Yeah.
Very bad at spelling. This is a very long
okay.
word.
You always write in uppercase. Okay, then you can say there are other kinds of quadrilaterals,
Yeah.
non-parallelograms.
Yeah.
And quadrilateral
Is
a polygon.
yeah. Now here you can have more interesting categorization. You can have polygons are also pentagons.
Ah, okay. So let me wait. Hold on for a second. Let me write this quadrilateral. Otherwise, people will not understand what this means. So pentagon.
Yeah.
Pentagon is a polygon.
Is a polygon.
I could write here triangle.
Yeah. And so on. You would get any n-sided polygon like this.
Suppose I say polygon and circle are of. Is there a category that higher than polygon? Circle and polygon are both what? What are
Both they would be closed curves.
they? Okay.
And then you would get ellipses. In fact, you could have ellipse here.
Ellipse. How can ellipse be a circle?
So an ellipse, similar to the rectangle, the square being a rectangle.
Okay.
An ellipse where the two foci are the same.
Okay,
is a
then it
circle.
becomes a circle. So
Yeah.
a circle is a special case of an ellipse.
Yeah.
Again, I guess you have to do this also, right?
Yeah.
Ellipse which is not
Non-circle.
non-circle ellipse.
Yeah.
Okay.
And then here you have closed curves, so you have other sort of closed
Irregular.
curves.
So what about this?
That would be one
Okay.
type of closed curve.
Okay.
Irregular.
Irregular.
Somewhere there.
Yeah. Okay.
Now you could even go. What about just curves?
Oh, something like this. Not closed.
Not closed.
I think that kind of arrow that you drew will be funny.
Ah.
You have to go up there.
Yeah.
Okay,
We
right.
can't really go up there, but we mean to go up there.
Okay.
And you could even go more
No,
up.
but let's do that. Let's do that, right? Otherwise, I can't reach there.
Oh.
Okay, erase that.
That.
Yeah.
What we can do is let's just continue that
No,
stuff.
just go up a little bit up to here.
Oh, okay.
Yeah, and then come down.
So
From there, yeah. From there, yeah. Yeah. Okay.
and this will be non-curves.
Non-closed.
Non-closed.
Non-closed curves.
Yeah.
Oh, that's neat. In fact, you have put everything that I learned in primary school
Yeah.
into a single diagram. But let me ask you now. You said something about the properties of a rectangle. If you do it this way, they will be inherited by
The square.
the square. So rectangle have 4 sides. So if by putting it this way, it means that square has 4 sides.
Yeah.
4 angles, and the angles are right angles. So all this sort of inherited from
Yeah.
the mother.
Yeah.
So can we say properties of mother are inherited by the daughters?
Yeah.
That's neat. That's
Yeah.
like biology.
Yeah.
Okay. Okay. All right. So show me how you have that kind of inheritance coming from, let's say, polygon,
Yeah.
from to here. what's the advantage of this in terms of inheritance? What do I know about squares?
Which you get
From this, yeah.
from all the way up.
Yeah.
Yeah. So if we start, let's start from rectangle to square.
Okay.
Let's do something simple.
Yeah.
So what is the area of a rectangle?
I'm going to write this down because I'm not going to remember it otherwise. Area of a rectangle is length multiplied by breadth. Area of a rectangle is length multiplied by breadth.
So what what is the area of a square? Because if a square is a type of rectangle. So what is the length of the square? What is the breadth of the square?
So area of a square is length is the same as breadth, right?
Yeah.
So
call that
length squared.
Yeah.
Okay, that's okay.
Yeah.
So I don't have to say anything about area of square. That I get it free.
Yeah.
From that picture.
Yeah. So now let's move up to here.
No, rectangle. I want to.
Oh, you want to do parallelogram?
Yeah. So why should I say rectangle is a parallelogram?
So what about in a parallelogram, opposite angles are equal, right?
Mm-hmm. Okay. Parallelogram.
Let me draw that.
Opposite sides are equal. Okay, that follows.
Opposite sides are equal,
Opposite
and also opposite angles are equal.
Opposite angles are equal.
Both of those.
And both are true about rectangles.
Yeah.
But not exactly what the angle is.
Not what the angle.
So all you have to do is to say one of the angles must be 90 degrees. It would follow that. Oh, yeah.
Also, the area of a parallelogram is height times the base.
Yes.
Not the length times the breadth, but the height times the base.
Okay, so let me write that down. Oh, okay. I'm going to erase this.
Yeah.
No, I will write it here. So this follows. So area of parallelogram is height multiplied by
the base.
Base.
Where the base is this length and the height is the length of the perpendicular drop down.
Right. So, but then the height in the case of a rectangle is the same as side.
Length.
So you get this one. You don't have to say that.
Yeah, and in the case of a square, the height is the side,
Sides.
and the base is the same thing as the base.
Okay, so you can derive the area of a square from the area of a parallelogram like this.
Yeah.
That's neat. That's neat. Okay.
Yeah. So
all right. And now I can see that essentially what you're saying is that properties of the descendants are inherited from the ancestors.
Yeah. So you don't have to repeat this, but you don't have to write this again.
Yeah.
That's there.
Right. So this is enough is what you're saying.
Yeah.
You don't need this.
Yeah.
Okay.
So then similarly, the sum of the angles of a quadrilateral are what?
Sum of the angles of a quadrilateral should be four right angles.
4 right angles.
Yeah.
So similarly, the sum of the angles of a parallelogram of a rectangle and a square
Right.
are also 4 right angles.
But for a quadrilateral, it's not necessary that every angle is 90 degrees.
Yeah.
Right. Okay.
Every angle could be any. There's no.
But the sum, that fact remains.
Yeah.
Again, you don't have to say anything about that being true about square. That you can deduce it.
Yeah. And now about polygon, the sum of the angles of a polygon are it's what? I keep getting confused about this. So it's
I think it's
twice the right angle times
side minus 1 or
side
something
minus
like that.
1 times the right angle.
If I remember still learning something. If a polygon has n sides, it is n minus 1 right angles. Is that correct? Or something else? No. Okay, triangle is let's do this. Okay, a triangle is 2 right angles.
Yeah.
So n is 3 minus 1, 2 right angles. Yeah. Okay. Quadrilateral is 4.
Yeah.
That wouldn't work. Because then it would mean 3 right angles. You don't want that result.
Look that up. We don't know what it is. But whatever it is, it's inherited already.
Wait. If you have a rectangle.
The easiest way to actually look at it is like this. The angle over here is the angle here is the total angle here is 4 right angles. 4 right.
No. Yeah, 4 right angles.
Okay. It's 4 right angles. And the angle of this is what?
So there are
4 triangles.
4 triangles. and that means 4 triangles multiplied by 2 right angles.
Yeah.
Right? So 6 right angles.
So eight right angles that will result in.
Yeah. 8 right angles. Minus
4 right angles.
4 right angles. So okay, you get this right.
Yeah.
You have 4 right angles.
Yeah.
What about triangle? This should be. Oh.
Yeah.
That's
That you can't do. Then for the
no. This is fine. But the 4 triangles.
Yeah. 1 triangle. So
okay.
Over here you would do. No, you would start from there and the center and do this.
Yeah.
And this is 1 right angle, and you can follow the same procedure as you go up.
Right.
And figure out. There is a formula also for it.
Yeah, we don't want to derive it right now. You can figure it out on your own.
Yeah.
Yeah. Okay. So essentially what you're saying is that it doesn't matter what the formula is.
Yeah.
If you have the formula for polygon, that would also hold for squares. You don't have to specifically state it for square.
Yeah.
That's actually very interesting, because what you're essentially saying is, if you state it this way, if polygon is the ancestor of square, then you are essentially saying that the ancestor's traits are inherited by the descendants. That looks exactly like biology, so that looks like a biological tree for me.
Yeah, it does actually. Yeah.
So do you think these things will apply to biological trees as well?
That the stuff is inherited? At least to some extent it should, right? There should be some.
Maybe we should talk about it in the next video.
Yeah.
We should do that. We should why don't we look at biological trees from this angle using graph theory? That might help us understand something.
Yeah.
Okay.
Okay.